What's wrong?
I thought we were on the expectations and variances.
We did that last time, didn't we?
Yeah.
So on to the next one.
Yeah.
Okay, so some of you, listen up, some of you might have noticed that I uploaded some Charles videos that I recorded during the break. So there's I think like 13 sample papers up on Moodle in the medical page with the answers, and then all the videos for each question. Okay. I was looking at the Charles website and I saw that the exam, according to their website, is something like the 5th of May, something like that. You saw that on their website? Yeah. So we'll do some preparation. I'm not even sure if we want to use the tutorial time to prepare for it. Okay.
Extra?
Huh?
Do we have extra classes for it?
We will have extra as well, yeah. There's a lot of, some stuff overlaps and some stuff doesn't. So we'll have to, if you're practicing the papers, my advice is to start with the more recent paper and work backwards. So I think the most recent one I have up there is M. A is the oldest one. Okay. And also I have 3 more exams I can add, but they're quite similar to the ones that are already up there. So we'll talk about that anyways, but I don't know. I'll have to talk to whoever it is, Tiago or Porg. There's quite a, how many is like about 10 of you doing the exam?
Yeah, around that.
Yeah, so that's a big enough number. So anyways, I'll see what we can do. Okay, so just to remind you, in case you forgot, last time we were looking at expectation. And if you remember, the definition is the sum of all the possible outcome values times the probability of those outcomes happening. I think we did variance as well. That's the sum. Didn't we do this as well? Yeah. That's the expected value of x squared minus the square of the expected value. Like that. That's the variance. Yeah. There's other definitions for it too. It's just this is the most convenient. I won't worry too much about other definitions. So what I want to have a look at is some formulas with expected value. So suppose I said, well, let's just do a quick reminder example. So let's just keep it simple. We'll just say there's 2 outcomes, 1 and 2, and the probability is 0.5 and 0.5. Okay, I'll give you a few seconds. It shouldn't take you too long to work it out. The expected value of x, what do you get here? What did we get? 1.5. Good. Okay. Now, suppose I was to ask you for the expected value of 2x. So if that's x, let me put down another table here. This is what 2x would look like. You'd have a 1 here and a 4 here. And the probability of each outcome is still 0.5. So let's calculate what's the expected value now for this 2x.
It's the same as x, c squared.
3, yeah. What's wrong? Oh yeah, sorry, thank you, sorry. 2 and 4, thank you. Expected value of 2x? It will be 3. Now, do you notice that that's twice as big as the answer you got previously? So you might wonder, is it a rule, if you get the expected value of 2x, is that the same thing as twice the expected value of x? Now, it's not clear if that's true to begin with, because after all, This here is not the same thing. So it's not exactly true that you can move things outside. But you can actually move constants outside, and the proof is quite easy. So suppose I ask you for the expected value of AX. That will equal the sum of PI times AXI. But you know you can pull the A outside because it's common in everything and it's a constant. So you can get A sum PIXI. Oh, and then you see, well, this is actually the same thing we had at the very beginning of the lesson. This is the expected value of X. So this is like our first rule. This is equal to A expected value of X. So in other words, you're allowed to pull constants out in front. So this, that's the proof. That's rule 1. I'll just write it again here. Expected value of AX equals A expected value of X. Okay? So if you can write that down, we'll have a look at another rule now. Got that? Not yet? Okay. Got that? Yeah. Scroll down? Yep. Was that a no? I have no idea who's talking right now. Continue or not? I can't hear her. Is that yes?
Give me a second.
Give me a second. Okay, alright. 2. Expected value. What about instead of adding a constant, or instead of multiplying a constant, you add one? Okay, so let's see. We might think, like if you were to guess, you might think it will be expected value of X, then plus the B at the end. Yeah. Let's see. Let's see what happens. So this is equal to, by the formula, the sum of PI XI plus B, which is equal to the sum of PI XI plus the sum of PI B. Because I'm like expanding here, okay? Well, this here, there's no surprise over what this equals. This is expected value of X. And here the B is a common constant, so I can take it out. So that becomes B sum PI. But does anybody know what this is? Sum PI. What does that simplify to? Mm-hmm. Somebody. Somewhere. 1. Yeah. 1. You know this. Probability adds up to 1. So this is sum X plus B times 1. So we get the rule, like we thought. Expected value of X plus B. You can take the B out, like that. Yeah? Yeah? So, if you like, you can put the two rules together as one. Expected value of AX plus B is A expected value of X plus B, like that. So that's the two rules together as one.
How's that done?
Hmm?
Alpha.
Well, like in the example I did at the start, there's no need to recalculate if the only thing you're doing is multiplying the x by a number or adding a number. I'll give you an don't worry, we'll do examples. Okay, continue. Continue. Yeah. So let's see, does the same thing work for variance of ax? Well, the definition is that's the expected value of ax squared minus the square of expected value of ax, like that. Okay. So just to be clear, that's expected value of a squared x squared minus expected value of ax times expected value of ax. Using our rule I have in blue here, we're allowed to take this out. So that becomes a squared ex squared. And here, again, using the same rule, I can take each a out. So it comes out as an a squared expected value of x squared, like that. Now you can see that a squared is common. You might spot what we have again. So you can see that's the variance again. So interestingly with variance, when constants pull out, they become squared. So you can say variance ax equals a squared variance of x. Okay, so if you can note that one. Got that? Yeah. Yeah. No surprises for what the next one we'll have a look at. Variance of x plus b. So that, let's calculate that now. Can I go down and do this one?
Yes.
Yeah, okay, so let's see what we get. Using the definition of variance, that's the expected value of x plus b squared minus expected value of x plus b, and the square is on the outside. So we're going to have to simplify a little bit here. That's the expected value of x squared plus 2bx plus b squared minus expected value of x plus b times expected value of x plus b. Okay. So we've learned from the first rule that expected value is linear. So using the first rule, we can change this into, you can think of this as if there was a 1 here, if you like. Expected value of x squared plus 2b expected value of x plus b squared. I'm actually just using, I know it looks a little bit different, but I'm actually just using this result here that says if you have a plus here, you can put a plus here. If you have constants, you can pull them out in the front. And if you have a constant added to the back, it just gets added to your answer. It's linear is what we say. So I can do the same thing here. those pluses come out as pluses here. Okay. The b squared is a constant. Although it's squared, it's still a constant, so it gets added to the end here. So, I mean, I'm just using the first rule here. I'll use the first rule here as well to change this into expected value of x plus b times expected value of x plus b. Okay, so let's expand again. X squared plus 2b expected value of x plus b squared minus expected value of x squared minus 2b expected value of x minus b squared. Now you notice a lot of stuff cancels. What cancels here? So obviously the b squared cancels with the minus b squared. This one here cancels with that one there. And you're left with something which you should recognize again. Expected value of x squared minus expected, yeah. Now this one's quite interesting. So it means that there's no effect with adding the b, which is perhaps surprising. But if you think about it for a moment, it'll make sense. So the rule is like this. And you can combine rule 3 and 4 to get this. Variance of ax plus b is equal to a squared variance of x. If we put the two rules together as one. Now, I'll explain why that result makes sense now, once you're ready. Yeah?
So we just don't use the d? Like,
Hmm?
we don't use the d at all? Like when
Doesn't have any effect. Now, the reason for this is, if you think about it, there's x, and there's some data. And let's take x and just add b to it. So if you picture it on the number line, it's as if you just move all your data to the right by b units. But remember, variance represents how spread out the data is. So by moving the data a little bit to the right, you change nothing about how spread out it is.
yeah.
So that's why the b, it makes sense that it has no effect, because variance measures how spread out something is. You know, if x represented heights, if you add 2 centimeters to everybody's height, you don't change how spread out people's heights are. You don't change the distance between the tallest and the shortest. So it does make sense. Okay. Can I scroll down? Yeah? So I'll just give you a simple example. So let's say you have x, and you don't know the table for x, but I tell you that its expected value, we'll say, is 2, and its variance, we'll say, is 1. But I don't actually give you the table. And then I ask you to calculate a couple of things here, which I'll let you practice. We'll do a more difficult one now next second. The expected value of 2x, 2x plus 1, variance of 2x, and give me the variance of 2x plus 1, and let's say also give me expected value of x squared. Okay, so there, I'll just give you couple of minutes just to try these short ones here. See if you can get the answers. Okay. We got some answers
Yeah.
here?
This was 4.
The first one, yeah. What's the first one here?
2 times
That's just 4, isn't it? And the second one?
5.
5. And this one here?
4.
4. And this one here? 4. And did you get the last one?
4 as well. 5. 4.
Well,
It's 4.
well, let's see. Let's see. So I tell you that the variance of x is equal to 1, and that's equal to the expected value of x squared minus the expected value of x with the square on the outside. So that means the thing that you want will be 1 plus the square of the expected value. Now, what did we say that was? We said that's a 2, didn't we? So that's 1 plus 4, yeah. So the answer then is 5 for the last one. A little bit tricky, that last one. A little bit tricky for sure. Yeah. Yeah, scroll down. Yeah. Okay. So look, here's a big advantage of these formulas. Let me give you an example. Suppose I give you two tables. Let's say x's could be 0, 1, 2. And let's just keep it easy. Let's say the probability is 1 over 3 for each. Okay. And let me give you another table, which is y. And let's say that could be 5, 6, 7. And let's make these ones a little bit different. Let's say a quarter, and a half. Yeah. And perhaps I'm not interested in x or y. Perhaps I'm interested in what the sum would be of x and y. So if we didn't have these formulas, you would have to do it like this. You would have to work out the table for the sum of x plus y. So the first possible value you could have is 5. And you could still have 6. And you could still have 7. And you could have 8. And you could have 9. Yeah? Now what's a little bit tricky now is working out the probability. So probability getting a 5 is if you get a 0 and a 5. So that would be 1/12. What about getting a 6? Well, that would be 5 and 1, wouldn't it? That's the only way to get it. Oh, it's 6 and a 0, sorry, yeah. So that 5 and a 1 is 1/12. 6 and a 0 is 1/12. That's 2/12. That's 1/6. And you can see where I'm going with this. So you go, etc. And then I ask you, what's the expected value of x plus y? So then you would do the usual thing. 12 times 5 plus 6 times 6, etc. And you realize, well, that's going to get very messy as soon as I have more than 2. If I have 3 or 4, then you realize the calculation is quite difficult. But as long as x and y are independent, they're in separate tables, you could actually use your formula. So instead of trying to calculate this, which is a bit difficult, or, well, not difficult, but time consuming, you could just say it'll be the expected value of x plus the expected value of y. And that's a lot easier to calculate, isn't it? So I think on this table that works out to be a 1. Oh, I don't know what it is here. It'd be 5 quarters plus 6 quarters is 11 quarters plus 14 quarters, 25 quarters. Is it 6.25? What's this one here? What is it?
Yeah.
I didn't like how much quicker I was. 6.25. So that's 7.25. Okay. And you could do the same thing for variance. So if I said what's the variance of x plus y, that's equal to variance of x plus variance of y. Now, don't be confused, because my rule that I gave you earlier is if you're adding on a constant, and I said it doesn't matter if you add on a constant, but this is a variable. So just to be clear, if you're dealing with variables, if I said expected value of ax plus by, that would equal a, expected value of the x variable, plus b, expected value of the y variable. Okay. And similar, if I said variance of ax plus by, that would be a squared variance of x plus b squared variance of y. And of course, if I had a plus c here, there'd be a plus c here. And if I had a plus c here, there'd be nothing here, because the adding of the constant doesn't change. Okay, so I think it's useful if you add or write these two down as well. Yeah, got that? Because these questions aren't involving a lot of calculations, it makes them a common section A question, because they're the type of question that you can do, like, for example, the last one here, where I ask you for this, you know, that would be a very typical section A question, because there's not a lot to write down.
4 marks.
Maybe 3 marks. Okay, you got that? Yeah. The square is actually interesting in the last one, because it means, if you think about it, if I ask you for the variance of x minus y, that would be the variance of 1x plus minus 1y, which according to my formula is 1 squared, variance of x plus minus 1 squared, which is 1, variance of y, which is actually variance of x plus variance of y. Now, you might have seen something like this without realizing it in, I don't know if you talk about this in chemistry, when you're doing your experiment and you're combining the errors.
Yeah.
Now, do you remember when you have two measurements and the rule for how the uncertainty combines?
Yeah.
Even if you're subtracting the measurements, what happens to the error? It doesn't subtract, it adds. Because of this rule. This is the reason why. Because one use of variance is a little bit like error in experiments. So if I said, what's the variance between measurement x minus measurement y? Because x and y are like variables, because each time you measure, you get a different number. So the variance between the difference here is the same as the variance of the x measurement plus the variance of the y measurement. So it's a plus. And I think your formula has squares in it. Yeah. And again, the reason for the squares in the formula is because the a comes out as a square here. Okay, so you haven't realized it. You've seen these rules already in chemistry. It's just you've no idea why you square or why you add, but this is the reason why then. Okay? So I'll give you, I'll let you try these for a few minutes before we go on to the next lesson. The next lesson needs the... oh no, it doesn't need the formula book. We're all right. Yeah. Okay, can I close this? Yeah.